So this was one of the trigonometry problems given in CBSE previous year's question 2024 paper, okay, in one of the versions of the paper. Okay, what they are asking us to do is that prove that this expression is equal to this expression. So how do you start with it? First, you take the left hand side, solve that left hand side, evaluate for this one and ensure that that is equal to this one when you do this. Okay, so let's get started. So the first and foremost thing is that the moment you get these kind of questions, right, you need to group them and use the algebraic formulas to solve it. Okay, so let me write the question first. Cos A minus sin A plus 1. Okay, so we all know, right, that we have this formula. A square minus B square is equal to A plus B times A minus B. I'm going to utilize that formula over here and solve this particular problem. So first and foremost thing what I'm going to do is that, look at it, I'm going to group them. So I'll make it cos A, this is one group, the first one, and I'm going to write it as sin A minus 1. Okay. Similarly, denominator, I can do the same thing. Cos A minus, I'll take a minus common here so that I get the same stuff over here. Look at it. This is A, this is B. A, B. Okay. So this becomes A plus B and A minus B. Now, what do I need to do? I have a option of A plus B and A minus B. So to rationalize the denominator, what I'm going to do is that I'm going to multiply it with this one in the denominator so that I can use the formula of A square minus B square and solve it. So what am I going to do? I'm going to multiply both of them with the numerator again. Okay, so look at it. So this becomes cos A plus sin A minus 1 ka whole square, because I am multiplying this one in the numerator, I am going to multiply that one in denominator. So this will become cos A minus sin A minus 1, right? This is what I have. I'm going to multiply it with the same, because I multiply it in the numerator. I'm going to do that same in the denominator as well. Plus sin A minus 1. Okay, let's go ahead and expand that. What do you get? When you expand these two, what do you get? It is A plus B ka whole square. It is A square. A square is cos square A plus sin A minus 1 whole square, that is B square, plus 2 times A cos A times B sin A minus 1. You're not using trigonometry at all over here. It's a completely algebra problem over here. Okay, now look at this one. This is A minus B and this is A plus B. So what do you get? You get cos square A minus sin A minus 1 ka whole square, which is A square minus B square. Okay, that's how you get. Now let's go ahead and open this completely. So what do you get? You get a cos square A in the numerator plus, when you open this, you are going to get sin square A minus 2 sin A plus 1, and this one plus 2 sin A cos A minus 2 cos A. That's your numerator. We have opened up everything, right? Now, in the denominator, what do you have? You have a cos square A. Open up this one. So what do you get? You get a sin square A minus 2 sin A plus 1, right? Now look at it. What is this? Cos square A plus sin square A is 1. Replace it with 1. We know that identity. Minus 2 sin A. Leave it like that. Plus 1. Plus 2 sin A cos A. Right? Minus 2 cos A. Okay, that's the numerator. Now open up this one. What do you have? Cos square A minus sin square A plus 2 sin A minus 1. Okay, that's what you have. So let me use the space above so that it becomes easy. That is what you got. Okay. So now look at this one. What do you have? 1 plus 1 is 2. So you get a 2 minus 2 sine A minus 2 cos A plus 2 times sine A cos A. Right? Divided by, what do you have here? What can I do over here? Look at it. Here I have cos square minus 1. Cos square minus 1. How can I, or what I can do is that I can take this one. Look at it. Okay. We know the identity, right? Sine square A plus cos square A is equal to 1. So sine square A will be equal to 1 minus cos square A, right? 1 minus, so but I have a cos square minus 1. Can I do a minus sign on both sides? A minus 1. I just wrote it. So I'm going to replace this and this with minus sine square A. So that becomes minus sine square A. I have another minus sine square A. Right? I have a plus 2 sine A over here. Look at it. Okay? So that is what we get. Okay, now look at the solution. So you have almost reached to the fag end of the solution. Okay, so what I'm going to do, I'm going to take a 2 common. When I take a 2 common, I get 1 minus sine A minus cos A and plus sine A cos A in the numerator. And here what I'm going to do is that this becomes minus 2 sine A, minus 2 sine square A. So I'm going to take say 2 common again, so let's write it. It becomes minus 2 sine square A and this is plus 2 sine A, right? That is what you get. So what I'm going to do is that, so you have a 2 over here. How can I write this one? This is a product of two basically terms. Look at it. Can I write it like this? 1 minus sine A times 1 minus cos A. Look at it. When you multiply these two, you're going to get this expression, right? Divided, I'm going to take a 2 common over here, minus 2 common over here, minus 2 sine A common over here. If I take a minus 2 sine A common over here, I'll take only 2 sine A. So I'm going to get minus 1 minus sine A. Look at it. Understood? Okay. This get cancels, this get cancelled. What are you left with? You are left with 1 minus cos A divided by sine A, which is equal to 1 by sine A minus cos A by sine A, which is equal to cosec A minus cot A, which is equal to RHS, and you have proved it. This is how you solve these problems. Okay, great.